For question 2, they say what is the acceleration of the object?
Yes.
What object are they talking about?
Question 1 and question 2 refer to the diagram below. So the object is the object in question 1. This object. Okay. Question 2, why is the answer B? I want to revisit a few terms. Say constant speed. Then there's constant acceleration. Then there's increasing speed. Increasing acceleration. Okay, what does this for mean? What does constant speed means?
It means moving at the same speed.
Yeah, moving at the same speed. So then, what about constant acceleration?
Increasing speed means getting faster.
What about constant speed, constant acceleration?
Don't know.
Don't know. Okay, that means I have to go through chapter kinematics as well. So acceleration is the rate of change of speed, change of velocity. So then you have this formula, which is A equals to V minus U over T. So that means if there is a change in velocity, there is a change in speed, there will be acceleration. So then, so that means in order for there to be acceleration, your velocity must be constantly increasing. Then for increasing acceleration, it means that if it's increasing acceleration, then the graph will look like that. That means the all like that. Wait, this is decreasing acceleration. Okay, when there's increasing acceleration, then your graph will look like the pink one. So the speed will increase more at one time. So of course, the increasing acceleration is not the highlight of this explanation right now. It's more like this constant acceleration that I want to talk about. So if you have constant acceleration, that means there is a constant change in velocity. So when there is constant speed, that means there's no change of velocity, then the acceleration is 0. And that's the explanation for question 2. And then I would like to point to this equation. We are doing dynamics, so I think there's this Newton's second law down here, which involves F net equals to mass times acceleration. So it also means that if there is 0 acceleration, that means so if there is no acceleration, that means there's 0 resultant force. Question 3. So it's like this. Initially, it might be moving in this direction. Okay. So maybe say against the 5 meters per second. If you choose the option that it will continue to move with the same speed, means you are saying that there's constant 0 acceleration. That you are telling me if you choose B, that means you're telling me there's 0 acceleration. But then because I brought up this, Because what happened is they say you use an external force. That means the force is no longer whatever it is. So this force will cause acceleration. So in some sense, that means the object will now accelerate because of that force that is applied. So answer C. Okay, question 5. Question 5 and question 7 is kind of related. Not, they're all using the same formula. Remember just now I said F net equals to mass times acceleration. So that means resultant force is mass times acceleration. For question 5, we say what happens to the acceleration of the object if force applied is doubled. So then they say assume the mass of the object stays the same and then floor is frictionless. That means floor is frictionless means there's no external force or there is no frictional force. So then if that's the case, they say what happens to the acceleration. So from here, can acceleration is force, resultant force over mass. So if the force doubles, so let's say the force now is 5 and then the mass is say 1 kilogram. So acceleration here will be 5 divided by 1. So it's 5. If you say question says the force is double. So now instead of 5, I put 10 double. So acceleration now become 10 over 1. So it's 10. So you compare these two answers, you can see that. Huh?
It increases.
So it increases, and one is 5 and one is 10. That means when the force is doubled, then the acceleration is also doubled. So that's why answer is C. Then for your question 7, they say which of the following balls will experience the least acceleration with when you have the same resultant force applied. So this is in kilogram. All of them are in kilogram except for this. So I will change this to in kilograms. So now back to that question. Let's say I have a force of 10 newtons and then I have a mass of 1 kilogram. Then the acceleration will be 10. What if I follow your answer, which is you use mass to be 20. So now mass is 500 grams, so 0.5 kilograms. So then force will acceleration will be 10 divided by 200. Force is 10, mass is 0.5. So it's only 20, right? So this is 10, this is 20. So if you pick another one, let's say mass is 5, then acceleration will be 10 divided by 5, so it's 2. So who will experience the least force?
C.
Yeah. Answer C. Number 10, this is what we did the last time. Okay, so the point that I made the last time was the idea of constant speed. So the idea of constant speed was when there's constant speed, acceleration is zero, right? Then the second thing is we draw the scenario. Then there are two cases, one which is force is 12 newtons and the mass is 5 kg. Then it moves at constant speed. That means this thing is going at acceleration equals to zero. Then the third thing is we need to know this formula, resultant force equals to mass times acceleration. Then so this down here tells you if acceleration equals to zero, resultant force must be zero. Right. Then another thing is how do you find resultant force? So if I have an object with one force, two force, resultant force will be
Force
two.
1 minus force 2.
Okay. Then if I have two forces, force 1 and then a force 2 going this way too, then resultant force will be
Force 1 plus force 2.
okay. So that's the summary we can get down here. And then back to this portion. Down here, acceleration is zero. That means resultant force is zero, which means there is a force acting on this that is causing the resultant force to be zero. So you will have to find out what is this F. So then we make use of this point here. You tell me one force minus the other force. So resultant force is zero. So force 1, force minus force equals to mass times acceleration. So 12 minus F is 0. So F is 12 newtons. So this is 12 newtons. So this is what I get from the first sentence. Then the question here asks if F is 18 newtons, what is acceleration? So again, back to that diagram. So I draw 5 kg. Force is now 18 newtons. And that purple force, right, is always there because it's friction. Apparently it's friction. So force equals to 12. Right. So resultant force equals to mass times acceleration. So force minus force equals to mass times acceleration. So 18 is the capital F minus 12 is equals to 5 kilograms times acceleration. So 18 minus 12 is 6 equals to 5 acceleration. So acceleration equals to 6 divided by 5. So it's 1.2 meter per second squared. That is the explanation for question 10. Then 1B, I noticed a lot of questions you put in the formula and then you just leave it hanging like that. So I assume you don't know how to continue. Can I assume that? Okay. So you have an empty truck, then it has a maximum acceleration of 4 meters per second from force F produced by the fuel. Acceleration is like that. So this is, assume mass is m. Then after that, it says that it has a second situation where this truck, which is m, carries a load which is equal to its own mass. Now, the force is still F. Then the acceleration is, don't know. Right? So I digest the question in this way. Can I say that? Is there anything wrong with my summary down there? So this is what you have. And this acceleration is F resultant force divided by M. Then you know this is 4. Then case 2, in this case, right, the mass is now 2m. Right. So I can take out the half and write F net over 2m. Now F net over m. Can I do that?
Yeah.
Then over here in the first part, this line down here, right, you see that this is 4, value is 4. And you see the same thing here.
Why have half bracket then F net over 2m?
Sorry?
Why have half then bracket F net over 2?
Because of this light. So the new case, so this is case 1, this is case 2. So from case 1, you get this value. So then you want to find, they say they want the acceleration for case 2. So then I restart and I put case 2, then acceleration is force over mass. Then case 2, you see down here, the mass is 2m. This is what you write down here. So then its acceleration is force divided by mass. So it's F net divided by 2m. So then I can rewrite it like that. So it's half times F net over m. And you know that F net over m is 4. So I put the 4 value here. Then it becomes half, the acceleration becomes half times 4. So it's 2. Question 2, for now, I think you may know how to do the question already. So as usual, I'll just draw it out. So a block of mass 6 kilograms. So the key to all these questions is to draw. Then it's pulled by a 30 Newton force, the 30 Newton. Then it moves with constant speed of 15 meters per second. So speed is 15 meters per second. What can you say about the acceleration? It writes constant speed of 15. So what does it imply?
It's moving at the same.
Sorry?
Moving at the same.
Yes. So what happens to the acceleration?
Constant.
Constant. So then constant, okay, the speed is constant, acceleration is
0.
okay. So then I can put 0 meter per second square here. Then they ask what is the resultant force. So resultant force, resultant force is mass times acceleration.
6 times 0.
So mass is 6 times 0, so 0. So first part A, 0 newtons. So the next part down here, I see that it's here and it writes calculate the frictional force. Okay. So because resultant force is 0, that means there must be a frictional force somewhere, and friction always opposes the motion. So it's if the diagram, the object is moving forward, that means friction will be going backwards. So then in this case, I examine this drawing again, right? Then I can say resultant force is F minus F is mass times acceleration, right? Resultant force is this, right? So 30 minus friction is 0. So friction is 30 newtons.
The frictional force is
30. Because resultant force is 0. So I have to redraw that diagram. Okay, so just now, oops. So just now it was like this, and it's being pulled by a 30 Newton. Then the friction is 30 Newtons. Okay, so friction does not change. So if the story goes and the object is still moving on the same surface, the friction will not change. Okay, you catch that? Very, very, very important thing there. Okay, this fact you must know. Then they tell you some other story. They say the block is now pulled with a 35 Newton force. Then they ask for the acceleration and they ask for the speed after this. So now they change this. This is no longer 30, it's 35. Then because the surface is the same, only the force change. That means the frictional force will still be the same. Then they want acceleration. That means resultant force is mass times acceleration. Resultant force is 35 minus 30. Mass is 6. Acceleration is I don't know.
5/6.
But science needs decimal place, so your answer should be in 3SF.
0.833.
Okay. The acceleration is this. Right. You wrote this here. This is all right. Then it's like it was at 15 meters per second, and then now the force increased. So that means the initial is 15. Then they say time is 3 seconds. Then you know acceleration now is 0.833. So it'll be 0.833 equals to V minus 15 over 3. V minus 15 equals to 3 times 0.833. Like that.
7.4. 17.499.
Yeah. So it's 17.499. Then we'll just leave it at 17.5 meter per second. 3. Then you say determine the resultant force. Yeah. So indicate the resultant force with the arrow P. Okay. Then that one, okay. Beware of units. Question 4a. You want to try again? A lorry has an acceleration of 3 meters per second square when it's empty. Determine its acceleration when it carries a load which is equal to its mass. So it was like that. Acceleration is 3 meters per second square. Then like that. So that means force is don't know, but the force remains constant. So force equals to mass times acceleration. So force equals to 3m. Then case 2. So now it carries another m. The force remains the same. Then acceleration is question mark. So force equals to mass times acceleration again. So mass now is 2m. Then the force is 3m from here because the force, pulling force doesn't change. Then question mark here is how much?
3m over 2m.
Yeah, yes.
Then they want to give a number for the acceleration.
They want a value for the acceleration. So we do this, then you get 1.5. Then 4b is not related, so I'll clear. 4b, you have okay. So you have a car. Whoops. You have a car. Then this car has a mass of 1,000 kilograms. So it is traveling at a speed of 10 meters per second. So then it goes on, and then a brake is applied here. When the car comes to here, it applies a brake. Okay, and it takes 5 seconds to stop it fully. So it will continue to move. 5 seconds later, it will be here, and the speed will be 0 meter per second. From here to here is 5 seconds. Then they say, what is the acceleration of the car? So acceleration is
For the average acceleration.
So you
V
have,
equals to 0. 0 minus 10 over 5.
yeah,
The breaking force is force equals to MA.
yeah, huh? So it'll be mass is 1000, A is 2.
1000 times 2, 2000.
A box lies on a of mass. So you have a box, mass 0.4 kilogram, stationary on the frictionless ground, no frictional force. It's good news. So it's not moving. A man applies a force of 1.5 newtons to it for 5 seconds. So I think it's gonna move. Calculate the speed of the box after 5 seconds. So your acceleration is found already. So remember this. Do I need to continue?
3.75 equals to
Final speed is what you want to find.
V minus 0 over 5.
Yeah.
Then it is 3.75 plus 0 times 5. 18.75. 18.75.
18.75.